We've been wanting to reply to Jay's high score on the Times by Extreme leaderboards for some time now. Jay can be, he has a bit of a smug face when he's in the lead, and frankly it bothers us, so we need to end that. Jay, I'm sorry, but your reign will end soon. So, the RIPJAY and RIPGN series has always been about doing everything short of just going to LN2. I've got a tank over there on my set. We can end this today. Jay, you'd have no chance. It'd be over. You'd be done skis. But we already had an LN2 battle, and it was with a different benchmark. It was with Port Royal, and it was supervised by Kingpin. It was for St. Jude's as a charity battle. A lot of fun. Today, though, we want to keep furthering the RIPJAY and RIPGN series by doing the MacGyver mods that Jay and I have been doing, where we try to push cards as far as possible without resorting to the easy method of liquid nitrogen. Before that, this video is brought to you by the Raycon Everyday E25 wireless earbuds. We've liked the Raycon Everyday E25s for their relatively long wireless range, something for which we've implemented a strict testing methodology that we've titled the Herculean Phone Toss. The E25s have 6 hours of playback time and include a socketable pill case with its own battery, so you get packaging that actually serves a functional purpose. The pill case can recharge the earbuds up to an additional 24 hours without needing a cable. The Raycon earbuds also come in multiple colors and include different inserts to help customize for the best fit. They're currently available for 15% off, linked below, or you can visit buyraycon.com/gamersnexus. So, we're going to be modifying a $2,500 Titan RTX video card well, that's what it used to cost anyway, with shunts. We're going to do a piggyback mod and attach a shunt resistor on top of a shunt resistor to increase the power budget of the card without needing to resort to LN2 to push the frequency higher. While we were in Taiwan, we bought some 8 milliohm shunt resistors at Guanhua Digital Plaza, and then we took them over to HiCookie, who is a professional overclocker who works for Gigabyte. And he helped us in modifying the card. I'm sure Jay will have a lot of complaints about this, and modifying the card to get the shunt resistors on there properly without breaking it. Now that we've learned on one and we've tested it for today's content, we can do the second one. So today we'll be showing our mod with HiCookie, he's featured in this, and testing with a lot of numbers for you on liquid metal for shorting the shunts versus a shunt resistor piggyback mod versus a stock card. So it should be fun to finally learn in numbers what all this stuff actually does. Okay, so this is pretty much a mod that anyone can do in a sense. We did go to a professional overclocker, as stated. We went to HiCookie. He's pretty awesome. He's one of the best overclockers for CPUs. He's a massive part of the R&D team for Gigabyte's motherboards, and he's been doing this a long time. But after he taught us the basics of how to do this mod, at this point we're fully capable of doing it ourselves, and likely many of you would be as well. It basically requires a soldering iron. You do need a high temperature. We'll talk about that in the clip we cut to with HiCookie later. And some shunt resistors and a bit of research beforehand. Now, a couple of things first. People always ask this question of, why don't you just short the shunt resistor with a wire? Well, that is a great idea. And in theory, it would work perfectly, because you just run a wire from one end to the other and you achieve the same thing. Potentially even better, because you're looking at even less resistance. But the problem is, the way NVIDIA works is if it sees too much power, or if you just short the shunt like that, what will happen is it locks itself into 2D clock mode. So you won't get the 3D clocks that you need to actually get scores or play games at all even. It'll lock itself down into a safety mode, and until you remove that mod, the card is functionally useless. It might as well be dead. All you'll get is desktop, and that's it. So these mods, same thing with the shunt resistor, same thing with liquid metal. One of the things we'll show you today is if you do too heavy an application of liquid metal, it'll do the same thing where it spikes really high in power consumption, then it drops to the floor and it craters. Or if you do a shunt resistor at, let's say, 5 milliohms instead of what we used, which is 8 milliohms on top of the existing 5 milliohm shunt resistors, if you do 5 milliohms on top of 5, you might end up, and in this case you would end up, in safety mode. So it would be useless. So 7 we've read is kind of functional, but we only found one report of that, and we saw multiple reports of 8 milliohms working, so that's what we bought. This is something that you could damage your card in the process, first of all, and after it you could also damage your card, because it's a hell of a lot of power going into this thing now. Quick recap on the NVIDIA boosting algorithm. The biggest limitations, first is power. NVIDIA limits to power because it's trying to maintain efficiency. That's the strongest point. And after you get past the power limitation, your next limitation is going to be temperature. frequency boosts based on how much power is available, and then after that, or depending, it'll boost based on how much thermal headroom is available. And both of those can be solved with chilled water for RIPJAY and with the shunt resistor mod, again, for RIPJAY. So we've done some of this stuff with liquid metal before, but nothing as good as this. One final note is that liquid metal we've never recommended anyway, because like the shunt mod, it can be dangerous, but for different reasons. If you apply it incorrectly, like at the base of the shunt, you get some liquid metal down there at the base where it's soldered on. It could end up wiggling itself off and killing the card eventually. We've never had that problem. We've left liquid metal on cards for over a year, and they've been fine. But it is very much your mileage may vary. Don't get it on the legs of the shunt. And separately, if you do too much, it's useless anyway, and then it's also a risk of dripping off and shorting something. So not really, it's fine for temporary use for competitive overclocking, not something we recommend on average. This, however, is much safer in every other sense, except for the power consumption skyrockets, so you might kill other stuff like MOSFETs. But let's jump over to Taipei, where we worked with HiCookie at Gigabyte HQ, and then we'll cut back to the test results.
Yeah, so now just piggyback.
Yeah.
Okay, yeah.
Yeah.
It should be easy.
So you already showed your soldering iron that you like using in the other video.
Yeah.
But the reason you like this one is because it heats up in 8 seconds to 200 degrees.
Yeah, it from 0 to 200 only 8 seconds.
So there's gonna be two that we want to short. There's this one and then one on the back. How often do you get the soldering iron out for projects these days?
Not many.
Yeah. Is that just because your engineers do it all for you?
Yeah.
Yeah.
这80后对。
你直接开到460以上，要不然应该不够。
不行哎。
那个好像
不行哎。哎，可以耶。
它的可以啊，它这光会吃。
我记得是500度，是不是？
对，类似的。
450而已。
So you're adding flux.
Yeah. And you need more temperature. Yeah, definitely need more temperature. And this one, I think it's up to 500 degrees. No, this one's 400.
Is it just because it's all copper in the PCB, I guess?
Yeah.
Yes.
So it's heat sinking it.
Yeah, I guess it's done. It's not perfect, but it's...
No, it doesn't need to be perfect. It just needs to be on there.
Okay, so let's try the other one.
Okay. Do you use any specific type of solder, like lead or?
For this one?
Yeah.
No,
No, just
find a good quality.
yeah. So what are you doing?
Yeah.
500 degrees? 400 degrees?
450 now.
450. Did you ever use liquid metal to short stuff out before?
No.
Just the pen?
Yeah.
Yeah. Yeah, you can use that for CPUs, right?
Yeah.
Like to trick the pins.
Okay.
Looks pretty good.
It should bypass the PCI Express old CPU, right?
Yeah, you trick it. Yeah,
Okay.
it tricks. I think the way I understand it is by changing the resistance because these are both for the PCIe cables.
Yeah, each one for each resistor for the one connector.
Right. Cool. Well, that from my perspective was easy because I didn't have to do anything. So thank you for doing the shunt mod. This will help me get a bit more power to it for the upcoming RIPJAY series revival that we're hoping to do with the 3970X, 3990X. So thanks for doing the mod. Appreciate it.
Yeah.
Before we get into the results charts for the hard mod and stock results, we wanted to illustrate what the power consumption looks like when too much liquid metal is used. So this would be the standard way to try and bypass power limitations, but it's not an easy way to do it because you basically have to go by experience for how much liquid metal you should put on the shunts. This is an amount where it's not as bad as shorting the shunt with a wire, which would lock us into 2D clocks, but instead where we get mixed power consumption consistency depending on the application. This chart shows DC current to the PCIe 12-volt cables against a constant 100% workload from FurMark. This load does not fluctuate and should never dip. We see a massive spike beyond the piggyback shunt mod, which we'll put on the screen in a second, up to 45 amps or a staggering 540 watts for PCIe 12-volt alone. But we also see power consumption crater unexpectedly. That's because the liquid metal application is too heavy, and although it allows more power through, it also starts tripping protective circuits or just exhibiting instability. Increasing the power budget also did nothing for this version of the mod, but we saw a similar fall off in performance. The liquid metal mod ended up crashing out of the test. The piggyback shunt mod, meanwhile, held about 31 to 34 amps constantly and is reliable in its stability. The stock card held about 19 to 23 amps constantly, also stable, but a lot lower. This illustrates that a liquid metal mod isn't so easy, since going too light on the application makes it a waste of time, but too heavy makes it unstable. It's hard to control, and the only way to really nail it is with experience. Our first bar chart is for power consumption at the PCIe 12-volt cables, tested with a physical current clamp. We're not measuring PCIe slot power draw for this test as it's irrelevant, and we didn't mod the PCIe slot shunt resistor, so it's going to be the same. This could also blow off the slot or melt the 24-pin connector if you mod that one, so don't do it. We only mod the PCIe cable shunt resistors. Power consumption is the first step toward understanding if this mod worked. FurMark puts the hardest load on the GPU and ensures a fixed 100% TDP. Remember that GPU power limitations are calculated against whether it's bumping against a 100% TDP limit, including if that TDP has been raised through OC software. And so we need something that doesn't have a variable load for easier testing. FurMark has the unmodified card at 238.8 watts, with the piggyback shunt mod from HiCookie doing 400 watts. That's a massive increase in power of 161 watts, or about 68% more power consumption from the mod. That's significantly more headroom for boosting too, but NVIDIA's efficiency normally plummets at this point in the curve, so it won't be anything close to a linear increase. Doing a reasonable amount of liquid metal, an amount where it's not nearly dripping off the shunt, we get about a 3% increase in power budget over stock. It's not much and not particularly helpful for pushing clocks. For the heavy liquid metal allotment, we end up all over the place, as we showed earlier. Sometimes it pulls more than the Shunt Resistor Piggyback mod, but then it randomly craters to 12 to 24 watts from earlier 500 watts. It's not very useful if it's going to crash and drop clocks, but we still wanted to show the peaks. Note that this is the marked in the legend as inconsistent, so don't consider these heavy liquid metal results as actually useful. Supplying 114% power to the GPU, the maximum allowed via the vBIOS, the unmodified card moves to 271 watts, or about a 14% increase, as you'd expect. The modded card goes to 455 watts. Both are about a 14% increase, as the vBIOS expects, but one is 55 watts and one is 32 watts. This is extremely simple math, but a lot of people get this wrong constantly in forums and on Twitter. This is something that people screw up when they compare things like AMD and NVIDIA cards, where you might have a 180 watt baseline and 50% power offset, and NVIDIA cards where you might have a 250 watt baseline and a lower power percent offset. Ultimately, a percentage is an offset from the base number, and a smaller base number means a lower absolute value for wattage. In this instance, the modded card is pushed extremely hard, nearing 500 watts for just the 12-volt cables. That's insane, and it's going to take serious cooling to keep the VRM alive. Time SPY power consumption was about 236 to 240 watts on the unmodified card, or 360 to 382 on the modified one. HiCookie's mod also increased our power consumption to 322 watts in gaming, where it was running about 240 watts previously. The light liquid metal mod has us around 3% improved once again, with the heavy liquid metal closer to the piggyback shunt mod, but still cratering inconsistently. Gaming results had us about 322 watts for the piggyback shunt mod, 240 watts for stock, and about 3% for the light liquid metal application. If you take a look at Hellblade though, you'll see where the heavier liquid metal application didn't pull much beyond the lighter liquid metal application. That's because, again, it's inconsistent and unreliable. This next chart will look at frequency in Time SPY Extreme, useful because it's functionally a perfectly repeatable result every run. For this one, we're looking at the unmodified card versus the piggyback modded card. The cards were maintained at the same temperature of 68 to 69 degrees Celsius GPU. This is without any overclock applied, so we're looking at only the stock behavior, which is going to basically follow the power limitations on the card. The stock card dips to about 1830 MHz in GT1 and about 1740 to 1800 MHz in GT2. Checking the logs, this card was power limited. It would have held higher clocks and boosted higher, but NVIDIA's boost behavior limits the card on power first to maintain efficiency. So we see this frequency draw back as power budget becomes too strained to support the higher frequencies with stability. The Piggyback modded card is drawing significantly more power and is horribly inefficient. You should never do this if you want it to actually be efficient. But it's holding about 1900 megahertz stable in both tests. You want a completely flat line here, and we're pretty close to that. At this point, since we're no longer significantly power limited, our next best method to push frequency will be by lowering the temperature. That's doable pretty easily with liquid nitrogen, less easily with chilled water, and pretty standard at least with normal water cooling. We also need to do some overclocking. For overclocking testing, we maintained an above ambient temperature of 68 degrees Celsius GPU to ensure the boosting algorithm behaved as normally. We later did some sub-zero overclocking with liquid nitrogen. This chart will show TimeSpy Extreme scores. It's our last one, and it's the most important. This helps us understand if there was actually any point to doing all of this. Remember, our goal is to chase points and scores, not to chase efficiency. This mod, again, is terrible for every other reason. We didn't sort this by points, but instead we kept a repeated order. The first 3 rows are all the unmodified card. Test 1 is full stock, test 2 is full stock, except with 14% power increase, so 114% power, no overclock applied, and test 3 is the maximum overclock for a stable result and 114% power. The order repeats for the Piggyback mod below it. The stock card scored 6976 points aggregate for GT1 and GT2 FPS results, while the Piggyback mod at 100% power scored 7527 points, an increase of 8%. Remember that 100% on the Piggyback is actually drawing significantly more since it was tricked into thinking power is lower than it is. Pushing power on the stock card increased the results to 7102 points, while the Piggyback increased to 7826. The gap is widening. Part of that's because 14% is again, a percentage. So total power consumption is higher. 14% of 33 amps is a lot more than 14% of 19 amps. The overclocked numbers on ambient were 8087 points for the unmodified card, while the modified card scored a massive 9163 points. That's an improvement of 13%, which is huge when considering we're at 68 to 69 degrees Celsius for all of these tests. The VRM would overheat in this configuration if we ran it sustained for longer than just TimeSpy, so we'll have to pull the card down to at least 0 degrees Celsius to keep it relatively alive for competitive overclocking. Liquid nitrogen will allow us to push the score higher still, of course, but we wanted to keep it simpler now. Note that we were using LN2 to control temperature for these results, locked to what the air cooler could do at 68C, but the modded Titan RTX required significantly more cooling power than the unmodified card. So we wanted to control temperature for frequency accuracy and for a direct points comparison, but it is not a direct power or thermal comparison. It's not really fair to the unmodified card in this instance. If you took the same amount of cooling power, it'd boost a bit higher from the frequency increase, but then it'd be at a lower temperature as well. So depends on what you want to compare. The stock card managed a 2010 to 2040 megahertz core frequency with a 190 megahertz offset. It held 2040 to 2055 megahertz in the final scene of GT1. And then the modded card, when we started really pushing it, was approaching 23 to 2400 megahertz. Wrapping all of this up then, first of all, quick issue we noticed with the AX1600i, the Corsair power supply. It's a smart power supply, and this is something we had to reach out to BuildZoid about for some help from actually hardcore overclocking. The problem with the AX1600i is even though you can switch it into single rail mode through software, it doesn't always work. So it would end up tripping over current protection when the card started pulling 30-something amps through the PCIe cables, which is somewhat unintended behavior, except when you switch it to single rail mode, it's not supposed to do that, so it's buggy. And we thought, I was genuinely worried for a second that the card had died in transit to and from Taiwan because, I mean, it was stuffed in a camera bag in a pouch for like 48 hours of flying. So we were worried it died, but in fact, switching the power supply to EVGA's Supernova T2 fixed it. That power supply, as BuildZoid described it, is a dumb power supply in a good way, in that it's single rail and there's no intelligent detection of current to try and protect the thing. So we switched the PSU and it was all fine after that. But yeah, it works very well. The frequency is higher, the overclocking capabilities are significantly higher, and we don't have the huge pain in the ass of liquid metal, which is always a massive pain because you have to be careful how you put the card down. You can't put it down flat on its back. It ends up like dripping off, or you end up accidentally bumping it with your hand when you're attaching the water block or whatever. It really sucks to work with. So this is a more permanent solution. It is not a solution we recommend for everybody, but it can be a lot of fun if you're trying to really get into the hard modding scene of enthusiast overclocking without going too deep into it. We're going to do this mod ourselves to the other card now, and then we'll start doing some streams again for the RIPJAY series. We'll start with probably water or chilled water because that's what Jay and I were doing. We try not to go into LN2. That's kind of the gentleman's agreement for this series. So we're just trying to mod stuff as much as we can without going LN2, and that's what makes it fun. Check back for that. We'll either do a stream or an upload. Not sure yet. The world is weird right now. But that's it for this one. Subscribe for more. Huge thanks to HiCookie for helping us out, educating us and the audience on how this stuff works. It's our first venture into hard modding, and it was a lot of fun. I'm looking forward to doing more of it. I'm sure many of you are experienced in this already, but I can appreciate that people like BuildZoid have a lot of knowledge on this, and we can learn from them as well. So subscribe for more. Go to store.gamersnexus.net to help us out directly, or patreon.com/gamersnexus to get some behind-the-scenes videos featuring other team members as well. We'll see you all next time.